Welcome to today's webinar with the title Interconnect Stress Test for Design Verification and Supplier Selection. I am Andreas Schürb, your host of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speaker of today's webinar is Mr. Helmut Trippel of our technical laboratory. And now I wish you lots of fun and new information.
Thank you very much, Andreas. Well, I will start off with the first slide here, where we want to give you a content overview. Firstly, we want to go into the basics of the Interconnect Stress Test to reassure that we're all talking about the same test and that we have a basic understanding of the test. Then secondly, we will go into current applications of the Interconnect Stress Test and look into what are current marks for using the Interconnect Stress Test. And thirdly, we will look into the quality planning and how the IST can be a part of the quality planning as well. And lastly, we will go into the support you can expect and that we offer from Würth Elektronik. Firstly, the Interconnect Stress Test is in accordance to the IPC-TM 650. What is the procedure for the Interconnect Stress Test? It's a testing of specific test coupons that represent the product. And in the test, you have a simulation of soldering cycles and lifetime cycles by a thermal load, which is applied by the current flowing through the coupon. What is measured in the Interconnect Stress Test? We have a resistance change in relation to the thermal stress, which is measured. And the resistance change is a failure criterion. So we have a relative resistance change as a criterion for failures, and based on that we can also determine at what cycles coupons fail. So what results does the IST provide? Concrete failure cycles of the test coupons, and the failure points can be detected as shown here. You can see that there's a thermal load on this coupon under infrared camera, thermal imaging, and we can clearly determine where a hotspot is, and the hotspot shows us the weakest link in the structure. Next we go to the current application of Interconnect Stress Test and look into when it's going to be applied. What are the applications currently? We see applications in the qualification process, either qualification of process, qualification of materials, or qualification of a product, at which point you would also need, of course, a test coupon which represents the product or the process or the critical components that you want to test the reliability of. Secondly, we have testing parallel to production, where a test coupon is required as well. And this is accompanying the product that you also design the test coupon and produce both at the same time in a serious environment. Thirdly, we have a test due to assembly or field failure. In this case, it would be nice to have an Interconnect Stress Test, but usually it's also a reaction to this failure. So in this case, you will have a test not directly accompanying the failure, but as a result of the failure, you would demand a test in this regard. Now let's look at a real-life scenario that we also experienced. We had a customer that had detected a failure of the printed circuit board in the assembly process, and this was a failure of the microvias in his product. This product was provided by a third party, and in this case, we were just the service provider for the Interconnect Stress Test, and the customer did his own research and determined that the IST is the best way for him to go forward as a check for reliability. With the feedback provided by the customer and by us, the suppliers were able to adapt the internal processes to improve the quality with feedback, and we were also able to retest that and ensure that this improvement is permanent, and he also defined for himself that he will do an IST test for himself before assembly of the product, as there are some critical components with a long run-up time, where you have costs and time, which cannot easily be replaced. So what is the influence of insufficient reliability in the product, and at what point is what is the cause of it? So when you have a failure in qualification process, the reliability of bare power circuit boards is uncertain. And we also experience a delay in start of production, as there need to be a retest, an improvement and a retest if the changes are suffice to prove the reliability that is required for the product. Secondly, we have a failure in test parallel to production. This can lead to a delay in deliveries of assembled products, and the reliability of assembled and bare power circuit boards is unknown in this case. And also the reliability of subsequent deliveries of the PCB power circuit board are unknown as well. Thirdly, on top of that, we have a failure possible in field operation. This is a uncertain reliability for the assembled product, and it's also a safety risk which can, depending on the application, it's a danger for person and the operation as well. Okay, so how do we think about this current procedure, and what further improvements can we do to plan more with the IST and not just have it as a reactionary mode enabled? In this cases, the reaction is needed and required, of course, but we would like to not to react to those circumstances, but to act due to early determination of the requirements that need to be in the product. In this case, is a test in response to deviation adequate? I would say from the supplier and the customer perspective, no, as we want to avoid any deviations that could lead to a failure, especially a field failure. Secondly, when should reliability be proven in the project process? In this case as well, I think if you prove and if you determine that reliability is needed and prove it as early as possible, you will have the best case scenario to act accordingly and to either do a optimization and a retest, or to have certainty about the reliability of the product. And so thirdly, what are the requirements of customers and suppliers about the proof of reliability? In both cases and for both sides, it's important to have this knowledge as soon as possible, either that the customer has the reliability, the certainty for himself that this product is reliable. On the other hand, for the supplier as well, as he is certain that he doesn't produce a product that might be dangerous to fail in the application or in the assembly process. So now let's look into the building blocks of the reliability and what parts they play. Firstly, we have the choice of material, which is very important for the reliability of the product, as a lower glass transition temperature can lead to higher expansion, and higher expansion rates also leads to earlier failures. Secondly, in the material, of course, the expansion rate itself is important to choose a material that is right for the application as well. Secondly, we have design choices of interconnect types, and this is, in this case, it's not just if I use plated through holes and micro vias, but also how I combine certain via types. Are they stacked? Are they staggered? And what design choices did I make? And also the thickness of the product is also something that has an influence on the reliability and the performance in the IST. Thirdly, we have the supplier as an influence, as different suppliers have different manufacturing processes and maybe different cleaning steps. And as there are a lot of steps required to build the PCB from the ground up, of course, this is a big point that influences the product as well, as you would be able to detect differences between different suppliers. Even if you have the same material and the same design, there can be different outcomes due to the supplier that you've chosen. Now, what is a planned application, and how can it look? Here again, real-world example. We have a customer who specified reliability as a critical factor in the project phase and exchanged with us about suitable test parameters, so he would be able to have the reliability that is required for his application. All potential suppliers produced the test coupons for the customer in this case, and the customer then came to us for the performance of the interconnect stress test in this case. And based on the results of the interconnect stress test, the customer was able to select the supplier based on the proof of reliability and the difference that he was shown in the results of the IST. In another case, the customer also required interconnect stress test for the product, but put the burden on the supplier so that he has a burden of proof, in this case, that he has to provide the IST documentation as well as product. So in this case, the suppliers produced the coupons and delivered those to Würth Elektronik. We executed the interconnect stress test at our facility as a service for the customer, for the PCB manufacturer in this case. And as we finished this test, we have seen that the number of cycles, reliability wasn't there for this case, for this product. So we gave feedback to the customer, in this case, the PCB manufacturer, how to improve on his processes and how to improve the reliability accordingly. And based on our input, he was able to implement those. And we also did a verification of the optimization implemented by retesting it. And we have seen a huge change, and the new number of cycles that he achieved in this case will suffice for the customer as well, for the assembly customer. So what are the advantages of scheduling the interconnect stress test? Well, there are two perspectives to this. One is the supplier's perspective, the other one is the customer perspective. On one side, we have the proof of reliability to customers that the supplier is enabled to do, which also can be a selling point in this case. Secondly, he is able to prove the reliability or the effectiveness of optimization of internal processes. For example, if the supplier has certain technology levels that he cannot build internally, that he needs to go externally, in this case, he is able to make an optimization based on the difference that he has seen and retest that optimization if it was effective or not. And thirdly, also design rules are different for different suppliers, and they may change with time as the market might require more miniaturization. And in this case, I can also prove the reliability of design rules and the change of design rules. Secondly, we have the customer perspective. Here, the customer can select the supplier based on the reliability proven by the suppliers. He has an assurance of the product before the production start, and he has knowledge about the reliability of design with different designs, how they affect the number of cycles and the reliability that can be proven. So now let's go into how we as Würth Elektronik can support you in your application of the interconnect stress test. What are the benefits from Würth Elektronik? We have experience as a printed circuit board manufacturer as well as a service provider. On one hand, we know the product, we know the production processes, we know the defect patterns, and we know the material fatigue of the product. On the other hand, as a service provider, we have know-how of the interconnect stress test, we have experience in the execution of the IST, and experience with services. We have customers both in power circuit board manufacturing as well as assembly and final customers. With those both sides, we have a good overview, not just about the test itself, but also about the test in relation to the product. So how does the service from Würth Elektronik look like? What can you expect from us? You can contact us for consulting and support from planning to actual results. So no matter in what phase you are in, if you have already done testing or if you're planning to do testing, or if you're thinking about planning to do testing, in any case, you can come to us for an exchange so as we can put you on the best path possible, and also do the testing and talk about actual results and what causes that. We also execute the Interconnect Stress Test in-house. We have we have like 4 IST machines for testing, and we also do an evaluation of test results and document this in a customer report. As I stated, a customer report or an evaluation is a microsection analysis of different failures, a statistical evaluation of the overall failures, and on top of that, a thermomechanical analysis of the structure with an extrapolation of test data. So you also are able to read out from high test temperatures to lower application temperatures. In this case, we also provide deep insight in what are the failure analysis in the microsection, what are the causes of failure, and what can be done to improve the reliability of the product as well. And in exchange, so that you are set on the best path to understand the IST test as well as a report, so you have an understanding of what you're actually buying in this case. Okay, I want to thank you all for your attention. So what are your requirements? And please feel free to contact us, and we will support you in your next steps. Best thanks.